In this video, we will be focusing on simplifying radical expressions using multiplication by the conjugate. So let's say we have an expression like 1 over 1 plus the square root of 2. The expression has the square root of 2 in the denominator, and we want to rewrite it without the square root, because for an expression to be considered simplified, there can't be any square roots in the denominator. Usually, we just multiply both the numerator and denominator of the expression by the square root. But this wouldn't work in this case, because the denominator has two terms. So let's say we tried to multiply both the numerator and denominator by the square root of 2, which is the square root in the denominator. So then this expression just becomes 1 over 1 plus the square root of 2 times square root of 2 over the square root of 2. Well, in the numerator, this just becomes the square root of 2, and then in the denominator, it's just 1 plus the square root of 2, all multiplied by the square root of 2. The problem with this is that once we apply the distributive property in the denominator, 1 times the square root of 2 is equal to the square root of 2, and square root of 2 times the square root of 2 in the second multiplication is equal to 2. So we can see that the second multiplication got rid of the square root term, but the first multiplication resulted in the square root of 2 term. So we're still stuck with a square root term in the denominator, so we're going to have to use a different method. So what we need to do instead is multiply the fraction throughout by the conjugate of the denominator. The conjugate of an expression with two terms is a new expression where the first term stays the same, but the sign of the second term is changed. So the conjugate of 1 plus the square root of 2 is just 1 minus the square root of 2. So this means we need to multiply the entire fraction throughout by 1 minus the square root of 2 over 1 minus the square root of 2. Notice how the first term, which is 1, stays the same, and the second term just has a sign change, so square root of 2 becomes negative square root of 2. So this means the conjugate of a plus b is simply a minus b, and if we are multiplying an expression by its conjugate, the product is just a plus b times a minus b, and that equals a squared minus b squared, as shown by the formula at the side here. Well, this is useful because the a squared and b squared terms would get rid of any square root terms, because any square root squared becomes an integer. So to combine this fraction, the numerator becomes 1 times 1 minus the square root of 2, and the denominator becomes 1 plus the square root of 2 times 1 minus the square root of 2. If we apply the distributive property, the numerator becomes 1 minus the square root of 2. The denominator is in the form a plus b times a minus b, so we can use the formula listed at the side. Since in this case, a equals 1 and b equals the square root of 2, the expression just becomes 1 squared minus the square root of 2 all squared, which corresponds to the a squared minus b squared in the formula. So this is just equal to 1 minus the square root of 2 over 1 minus 2, because the square root of 2 squared is equal to 2. And this is just equal to 1 minus the square root of 2 over negative 1, since 1 minus 2 is equal to negative 1. So if we distribute the negative 1 over the numerator, this expression becomes negative 1 plus the square root of 2. And now this expression doesn't have any square roots in the denominator, since there's actually no fraction. So this expression is considered simplified. So let's look at another example. To simplify the expression, we need to first look at the denominator, square root of 2 plus the square root of 3. What we need to do now is multiply the fraction throughout by the conjugate of the denominator. To find the conjugate of the denominator, we need to keep the first term the same and change the sign in front of the second term. So the conjugate of square root of 2 plus the square root of 3 is just square root of 2 minus the square root of 3. So now we just rewrite the expression and multiply it by square root of 2 minus square root of 3 over square root of 2 minus the square root of 3. So now this just becomes 1 times square root of 2 minus the square root of 3 in the numerator, and square root of 2 plus the square root of 3 times square root of 2 minus the square root of 3 in the denominator. If we apply the distributive property, the numerator just becomes square root of 2 minus the square root of 3, and the denominator becomes square root of 2 all squared minus the square root of 3 all squared if we apply the formula a plus b times a minus b equals a squared minus b squared. So this is further simplified as square root of 2 minus the square root of 3 over 2 minus 3, since square root of 2 squared is equal to 2 and square root of 3 squared is equal to 3. This further simplifies to the square root of 2 minus the square root of 3 over negative 1, because 2 minus 3 is equal to negative 1. And if we distribute the division over the two terms in the denominator, this becomes negative square root of 2 plus the square root of 3. And we can see that there's no longer any fraction or any square root terms in the denominator. So this expression is considered simplified. So here's an example where there's a negative sign in the denominator. Since there's two square root terms in the denominator, we need to multiply the fraction throughout by its conjugate, as always. The conjugate of square root of 7 minus the square root of 3 is square root of 7 plus the square root of 3, since we're keeping the first term the same and flipping the sign for the second term. So the minus square root of 3 becomes plus square root of 3. So we'll rewrite this expression and then multiply by square root of 7 plus the square root of 3 over square root of 7 plus the square root of 3. So this becomes 1 times the square root of 7 plus the square root of 3 in the numerator, and the square root of 7 minus the square root of 3 times square root of 7 plus the square root of 3 in the denominator. If we apply the distributive property in the numerator, this becomes the square root of 7 plus the square root of 3, and the denominator is in the form a minus b times a plus b, where a is equal to the square root of 7 and b is equal to the square root of 3. So that just equals the square root of 7 all squared minus the square root of 3 all squared, which corresponds to the a squared minus b squared. So this expression can be further simplified as the square root of 7 plus the square root of 3 divided by 7 minus 3. And the 7 minus 3 just equals 4, so this equals square root of 7 plus the square root of 3 over 4. And this expression is considered simplified since there are no longer any square root terms in the denominator. So here's a slightly more difficult example. There are two square root terms in the denominator, 4 square root of 5 minus 2 square root of 11. So we need to multiply this fraction throughout by its conjugate. The conjugate of 4 square root of 5 minus 2 square root of 11 is 4 square root of 5 plus 2 square root of 11, since we're keeping the first term the same and flipping the sign of the second term from negative to positive. So we will rewrite the expression square root of 2 plus the square root of 3 over 4 square root of 5 minus 2 square root of 11, and then multiply this throughout by 4 square root of 5 plus 2 square root of 11 over 4 square root of 5 plus 2 square root of 11. So now we need to combine the fractions by doing the multiplication, and the numerator becomes square root of 2 plus square root of 3 times 4 square root of 5 plus 2 square root of 11, and the denominator becomes 4 square root of 5 minus 2 square root of 11 times 4 square root of 5 plus 2 square root of 11. We just need to do the multiplication by applying the distributive property now. So in the numerator, the first multiplication is the square root of 2 times 4 square root of 5, and the second multiplication is square root of 2 times 2 square root of 11. The third multiplication is square root of 3 times 4 square root of 5, and the last multiplication is square root of 3 times 2 square root of 11. And then in the denominator, we have the expression in the form a plus b times a minus b, where a is equal to 4 square root of 5, and b is equal to 2 square root of 11. So this just equals a squared minus b squared with the respective values. So this denominator is just equal to 4 square root of 5 all squared minus 2 square root of 11 all squared. So the only thing left to do now is to simplify some terms. In the numerator, square root of 2 times 4 square root of 5 is equal to 4 square root of 10. Square root of 2 times 2 square root of 11 is equal to 2 square root of 22. Square root of 3 times 4 square root of 5 is equal to 4 square root of 15. And in the last multiplication, square root of 3 times 2 square root of 11 is equal to 2 square root of 33. So in the denominator, 4 square root of 5 all squared becomes 16 times 5, because 4 squared is equal to 16, and square root of 5 squared is equal to 5. And then 2 square root of 11 all squared becomes 4 times 11, because 2 squared is equal to 4, and the square root of 11 squared is equal to 11. Well, now the denominator just equals 36 because 16 times 5 is equal to 80, and then 4 times 11 is equal to 44, and 80 minus 44 is equal to 36. So this expression is just equal to 4 square root of 10 plus 2 square root of 22 plus 4 square root of 15 plus 2 square root of 33, all divided by 36. We can distribute the division here and rewrite 4 square root of 10 over 36 as square root of 10 over 9. And the 2 square root of 22 over 36 can be rewritten as square root of 22 over 18. And then 4 square root of 15 over 36 is just square root of 15 over 9. And then 2 square root of 33 over 36 is just equal to the square root of 33 over 18. And now this expression is simplified. And this is our final answer.